Alrighty, so the midpoint and distance formulas. So we looked at in previous lessons how we could describe 2 points using essentially generic points, so like an x1 or y1, and an x2 and a y2. And from that, we were able to turn these 2 points into an equation using the point gradient formula. And we found the gradient using y2 minus y1 is equal to, or over x2 minus x1 to find the gradient, and then using a secondary point and a generic point, x and y, and substitute it in and rearrange, and we could get an equation. Today, we're going to be looking at the midpoint and distance of an interval. So a line between two specific points. So what we'll do is we'll look at it generically first, okay? And then after that, we will look at an example where we're actually using some numbers, okay? So first up is formulas, then it's numbers. And basically, the point of the formulas is it shouldn't matter what 2 points I give you, okay? As long as you know what the numbers are, you can substitute them into the equation, and you should get the midpoint and the distance, depending on what you're trying to find. So here's our two generic points. So we've got the first one here, which is x1, y1, and the second one here, which is x2, y2, okay? And so these 2 points are going to be treated as our like generic points. So one of the points might be 2, 3, one of the points might be -5, -7. It doesn't matter, but they're just two generic points. Now, for length, we can use our knowledge of Pythagoras' theorem, okay? So treat this interval like a right-angled triangle. And in fact, the picture is drawn here for us. So as long as we know this distance here and this distance here, we should be able to find what the length of the interval along here is, okay? And we can use Pythagoras to do that. Now, in year 9, we typically teach you that's the case, and in year 8, we sometimes assess you on this too. We can say, okay, well, if I've got 2 points like this and we know how to find intervals and such, how would I go about finding the distance? So what I'm going to do today is I'm going to show you, well, a generic formula that will work no matter what. And here it is. So the distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So in other words, in more plain English, it's just the difference between the x values squared plus the distance between the y values squared, because we're making this right-angled triangle. And as I said, as long as I know the distance between my x values and then the distance between my y values, I should be able to work out what that length is and then be able to use Pythagoras to find it, okay? So this length down here is our y2 minus y1. This length across here is our x2 minus x1. So whatever the x value is, you take one, you subtract it from the other. Now I will make sure, or I should say, you should make sure that the 2 points, so if you're using x2 first in your initial spot, you make sure you use y2 first in this initial spot here. Now it doesn't make too much of a difference for this one, like it did for the gradient. Because when you take the difference, okay, it doesn't matter if it's positive or negative, you'll either get one or the other. When you square it, it'll just turn it back into a positive anyway, so it doesn't matter too much. Now, here's our 2 points again, and the midpoint this time. So the midpoint is finding the average of the x values and the y values. So in other words, if I look at the difference between the two y's, and I'm looking for the halfway point, okay, of these two values here. So the y values midpoint is about there. I do the same thing for the x values. So I'm looking for the midpoint, the halfway point of my x values, and we find it to be about there. And then so what we get then is just we create a coordinate that's midpoint is halfway between the x's and halfway between the y's. And so if we do this, we end up with a formula that looks like this. Now, what you need to make sure you do with this formula is that it becomes a coordinate, okay? We're not adding these two things together, okay? It's two different numbers because it's a coordinate that we're trying to get. The midpoint is a coordinate. So our formula is x2 plus x1 divided by 2. So it's an average, right? You add the two numbers and divide by 2. And the second part for the y's is y2 plus y1 divided by, that should be a 2, not a 1. So we're dividing both of them by 2 because it's an average. We take two numbers and divide by 2, okay? So by doing this, this allows us to find what the midpoint is, okay, using these averages. So here's an example. Find the distance between the midpoint and the coordinates -3, 8, and 4, -1. Okay. We don't have to draw a picture for this one. We can just jump straight in and work out what the answer is going to be by using our formulas. So let's do that. We'll start off with the distance. So distance is equal to, okay, it's the square root of y2 minus y1 squared plus x2 minus x1 squared. Now you'll notice that I've done this the other way around compared to the previous page where I had the other formula, x2 minus x1 or y2 minus y1. In fact, if I go back to that particular page, you'll notice that we had x2 and x1, y2 and y1. Okay, that order doesn't matter for this particular bit because you're just adding what the results are together. It doesn't matter if I do 3 plus 5 or 5 plus 3, I'll end up with the same thing. So as long as these bits inside are the y's and the x's, it doesn't matter which way they go around, it will still work. Okay. Now, I like to label my points before I continue after this point. So x1, y1, x2, y2, okay? So these 2 points here are my generic, well, like my values, right? My x and my y values. I'm going to take each component, I'm going to substitute it into the location that's required. So when we're doing this, be very careful because -1 means we need to put the whole -1 in there, okay? Because the distance between -1 and 8 is significantly different, well, partially different, to the distance between 1 and 8, okay? It is a difference between the two because we're trying to find the distance between the two. And then for the second one, x2, which is 4, minus x1, which is -3, okay? It's very important that we have it that way around, and it's squared. Distance is equal to, okay? Well, from here, we've got everything that we need. Let's just substitute it straight into our calculator. -1 minus 8 squared plus 4 minus -3 squared. And of course, our distance then becomes 11.40 to 2 decimal places. So that's a distance. Now for the midpoint, okay, we're going to use the other formula. Now for this one, it's really important that we do put the x's on the left side and we put the y's on the right side because that's how a coordinate is read. It's the x values first and then the y values second. Easy way to remember it, alphabetical order. X comes before y, so x goes before y. Now again, it doesn't matter which one I do first, my x and my y, okay, because we're adding these two together. So again, it doesn't matter if I do 3 plus 5 or 5 plus 3, I'll still end up with 8 no matter what. But to keep it consistent, we're going to do 4 minus 3, so plus minus 3, positive and negative become a negative, over 2, comma, minus 1, plus 8, over 2. 4 take away 3 is, of course, just equal to 1. So my x coordinate is a half. My y coordinate, minus 1 plus 8, is equal to 7. So that is 7 over 2. And so that is my midpoint. Very straightforward formulas, okay? Very straightforward formulas. The only thing you need to make sure you do is labeling your coordinates correctly and, of course, using the formulas correctly too.